So now let us see the continuation of the yesterday's theorem, the statement, the important theorem, where I told you the title of this theorem 4.7 is Characterization of a Bipartite Graph. So the statement of this characterization of a bipartite graph is G is, G is said to be bipartite. Whenever G is said to be a bipartite graph, you will see when it contains a cycle, the cycles will be of even length. This is what the statement about, which is an important character of any bipartite graph. So we understand graph which is bipartite said to be always a connected graph. When it is going to contain a cycle, the cycle will be of the even length. So in the previous video we have seen, I have told you the technique of proof over here is, because it is an if and only if condition, we consider one of the side is we assume to be true, we prove the other part, and vice versa we do for the other side. So we have completed the first part of the proof. We assumed we assume the left hand side, that is we assume the given graph is a bipartite graph such that this bipartite graph has got a cycle in it, and we proved it is that cycle's length is of an even value. So now we are going to prove the converse part. The converse part is, let us given be a graph G that is going to be a connected graph where it contains a cycle which is going to be of an even length. This is going to be given for me. I have to prove it is a bipartite graph. So now we are going for a converse part of the proof. What is the converse part of the proof, or what is given to us in the converse part? What are we going to prove in the converse part? The given statement in the converse part is, I have a graph G such that it is a connected graph which contains a cycles in it number. So what do I have to prove? I have to prove that this G is a bipartite graph. This G is a bipartite graph. This is what I have to prove. So if I have to say I have to prove it is a bipartite graph, it is all about the graph G. The graph G has got a vertex set V, where vertex set is partitioned into V1 and V2. All this will be given to me. So the only part I have to prove it is a bipartite graph means there exists a line joining from V1 to V2. The moment I prove this part, the result is true. So under this assumption, what all it is going to be? The considered part of a proof. I am given a graph G which is connected, whose vertex set is partitioned into V1 and V2. So this connected graph will have a cycle in it whose length is even. So the vertex set V1, V2 is going to have the length such that it is going to contain an even length whichever forms a cycle. This is what our given statement. From this given statement, we are going to prove there exists a line joining from V1 to V2. So let me define what is V1, or how the nature of V1 vertex set subset present, and what is the nature of a V2 vertex subset. So for this we are going to construct something. Let us construct V1 is equal to set of all elements V in V, so that the distance between V comma V1 is going to be an even quantity. So you have to recall something called distance here. So I have already defined you the definition of this metric distance. One can find a distance between 2 points when there exists a path in it. So because we are given a connected, there exists a connectedness, obviously a path is possible. Because a path is possible, one is in a position to find the distance between the 2 points. So now I segregate it. When any vertex set happen, we will definitely come across the distance is found to be even length, the distance is found to be odd length. So let me define or construct V1 is a set of all vertices such that the distance, whichever the distance is going to be even length, that is going to be called as subset V1. Like that, we are going to